Okay, students, assalamu alaikum. So today we will discuss about machine learning using Scikit-learn. So Scikit-learn एक machine learning की library है and it is open source है, सबके लिए open है और available है using their website. So you can install it by according to your operating system and your desire. So what we will be using it later on for the practical purpose और इसको हम PyCharm एक टूल है Python में और उसके थ्रू हम इसको practically execute करेंगे. So we will go through some basics first, and then we will, in the next part of this lecture, we will go for the tutorial practical implementation of algorithms. So it is an open source library, machine learning library, and it has both supervised and unsupervised learning methods built in this. And not only that, it provides various tools for model fitting, data preprocessing, model selection, and model evaluation, but it has many other utilities as well. So it is a very complete library, and unlike many GUI-based software, it provides you a great control over your data and what should be applied and what should not be applied on it. So in order to start our machine learning journey with the Scikit-learn, we need to understand two basic concepts. One is estimator, other is fit method. So estimator is actually method built into the this particular library, where you can access different machine learning algorithms and models, and so each algorithm or model is called as an estimator in Scikit-learn. So the fit method is used for training the data. So basically, when you will be using a fit method in the machine learning in Scikit-learn, so actually you will be constructing a model out of the training data. So just like in linear regression, we have a straight line representing our data. So and if we have logistic regression, we have a sigmoid curve. So for complex data sets, we have different patterns, complex patterns in the data. So the fitting is different. with the introduction of fit and estimator, I would also like to emphasize the term we normally hear about overfitting. So overfitting is like when your model is trained on the so much on the data that it has covered all the data points, and it has absorbed or it has taken into account all the complexity of the model. So that is overfitting. So we don't want overfitting of our models, because it will result into very bad generalizability on the test data set. So we want a good generalizability. So we have to intelligently select the parameters where we can avoid overfitting. And particularly the parameter which is very important is that the size of the test data, and also how you are dividing your training and test data set into different chunks. So this is just an example. This is for the random forest classifier. A random forest, as you know, that is ensemble methods. And in the first line, we have just imported it from the Scikit-learn. The second line, we have just initialized it and stored it into separate variable. And this is a numpy array, x and y. Here, x is our data, which includes the 2 samples and 3 features, and y is our class labels. So fit method normally takes 2 inputs, as we have seen that as clf.fit x and y. First one is our obviously sample, our data itself, and y is second one is our optional one, which is our actually labels. So that if the target, if we are going for regression task, then the y, that means the data labels are normally real numbers, and if we are going for classification task, then the y is normally integers. And for unsupervised learning tasks like y does not need to be specified, specifically when you are going for the clustering algorithms. So you don't need y, because in a clustering you don't have data labels already into the data. So you want to cluster them because you don't have data labels available. So that is the story behind this. But the main story is that highlight is that you have a fit method which takes two input, and first one is data and second one is your data label, and both are actually both of which are arrays, and we store them as arrays firstly, and or manage them as arrays, and then we access them into the fit method. And this fit method is accessed with reference to a particular classifier, in which case random forest CL is which is represented by CLF variable. So CLF is representing here as random forest classifier. So this is what I have already told you. So like if fitting, we have a predict method, and we also have a score method. So both of these methods are used to predict the you can say classes of training data. That means you can predict what on the model you have learned, and this is the outcome of this. This is an example of this. So we also have it, apart from estimators and predictors, we also have transformers, preprocessors. So machine learning workflows can have different parts. You can have transformations and preprocessing modules, and also you can have predictors or estimators. So you can construct a pipeline which can include transformers or preprocessors and predictors. So what this pipeline can do, that once you have included or input the data into the pipeline, so it will automatically first pre-process the step, pre-process the actually data, and transform the data into some format which is manageable by, which is acceptable by the estimator itself, and then it will input the data into the predictor or estimator and to predict the final outcome of it. So this is all this coming from this is just an example. So this is part of pre-processing module and in the API, and this is just standard scaler and does the scaling standardization, and you just need to use the fit method for that, and fit.transform, and for because we don't need variables for it, so we will only be inputting the our you can say data into it. But obviously why that means the labels are optional here. So this command here, what it does, it transforms the data into it is standardize the data into a format which can be then later on input into the predictor estimator. So pipelines I have already described. We have built-in datasets as well, and we have a functionality of a pipeline as well. So we can build pipeline using a make pipeline function class, and we can just like in this example. So make pipeline is a method from the library, and we have initialized two different you can say methods here: standard scaler, which is used for transformation, and logistic regression, which is a machine learning algorithm for used for regression. So basically when we made the pipeline using make pipeline, we have stored that into pipe a variable. You can name anything. And similarly, we have you can see that we have IS dataset already built provided to you with the machine learning library Scikit-learn. So we just have to call it import it using load iris, and load iris is also initialized by default. The value it it will not return value. So a return value is a, xy, return xy is a false, but we will make it true so that we can import its variables, sorry, data labels, and the data itself into the both of these variables. So x here will get all the data, and y here will get all the data labels. So similarly, we have train test separate, which is also a method from the library. So it actually, like here from Scikit-learn model selection, we have imported the train test separate. So train test separate actually here it takes the two arguments, necessarily two arguments, which are arrays, and also there are additional arguments which we will see in the you can say during a practical session. So once we did that, so we have two types of in fact four types of arrays here, true for training and true for testing. And for training, one x train, for example, here is include the data, and x test got the testing data, and y train get the labels of the training set, and y test got the labels for the testing data. So one thing to remember is that when we store that in the form of two separate arrays, x and y. So x and y, the for a particular instance or for particular observation, the training label is at the same index position in the label array. So for example, for in x train, there is a record or instance at index position 1. So its data label will be, or its class will be in the y train, where its data label will be in the first index position. So index position should be the same, will be the same. So next thing is very easy, just fit it to the training and testing, because we build our model using training data. So it's x train is our data, and y train is our data labels for training data set. So we have used the pipe.fit method. So pipe includes both the standard scaler and logistic regression. So first it will do the scaling, and then we'll apply the we'll build the model using logistic regression. And next thing is you are calculating the accuracy score using prediction method. So we are using predict method here, and on the test data set. Okay, and then model evaluation is very important. So fitting a model to some data does not entail that it will predict well on unseen data. So this needs to be directly evaluated. So we have two kind of you can say separates available. One is train testing separate, other is cross validation. In train test separate, a particular percentage of data is separated from the main data set as it for training data, and the rest of the goes into the test data set. So we build our data set into on the basis of training data, and then apply it on the test data set. So basically, what this does actually, this will result into feature selection bias. So feature selection bias is very common when you are separating the data in this particular way. For example, if we are taking 60% of the data as a training, so which 60% of the data do we need to take? Is it from the beginning of the data, or from the last 60%, or middle 60%, or randomly? So either case is you are not taking into account 40% of the data, and that 40% data may be important for the training or model building process, which can improve its generalizability. So we avoid this feature selection bias using cross validation methods. So cross validation is just like we divide our data into equal folds. For example, if we are saying 5-fold cross validation, so we divide our data into 5 folds, 5 chunks, and we train on 4 and test on 1. And consecutively, we repeat this process 5 different times, and each time we use it a different chunk for testing, and rest of the chunk, rest of the 4 force will be used for your training purpose. So these are two methods are available, and this is just an example where we can see the linear regression is being done using cross validation. So when we're doing the practical, we will see the cross validation and the difference between cross validation and test train test separate as well. So this is all for now, and we will for practical, please go to the next lecture. Thank you.